Morning, ladies. Oh, it's not morning, it's afternoon. But you don't know that. You could be watching this in the evening. You could be watching this at 5 a.m. I don't know. So good morning, good afternoon, good evening, whenever you're listening to this. All right, so 8D, we're looking at conditional probability. So conditional probability kind of differs because something actually has to happen for another event to occur. So it's kind of like looking at a deck of cards and you're saying, what's the probability of getting an ace given that the card is red? Okay, so you're only looking at the red cards. So you're only looking at half the pack, 26 cards. And how many of them are an ace? There's 2. So 2 out of 26, or simplified to 1 over 13, would be your probability. So your conditional probability is represented by this line here, and that line is called given that. All right, so probability of A given B. And this is your formula. It has to be in this order. Okay, so if it's A given B, then it's the probability of A and B over the probability of B. So just make sure you're consistent with your events. So B is on the bottom there, but if it was the other way around, so the probability of B given A, then A is on the bottom. So their intersection, remember this sign here, meaning and, so probability of A and B over the probability of A. All right, so I'm just reading through. Okay, I think that's all good. Okay, I'm just trying to figure out what it's actually saying here. So if you were doing probabilities, remember probability we usually write as a fraction or a decimal. So basically you just need to look at the numbers, all right? So you don't need to write the probability being a half over, gosh, I shouldn't do a half. Let me just think of something. 1/3 over a half. Okay, you can just simplify it using n, the number, and that might probably make more sense when I start doing a question. All right, so this point here, the probability of A given B differs from probability of A in that the sample space is reduced to the set B, okay, as shown in these Venn diagrams. So we're only looking at A given B, we're only looking at what we have in the B. So given B, a B has to have occurred, and we're only looking at this intersection part because that part contains A. So the probability of A is in this intersection. Oh, I always use this pointer, and I just watched a video the other day and I realized you can't actually see my pointer. So when I start doing things, maybe I should start actually pointing to them. All right, so let's do some questions. And a noisy plane has just gone overhead. That's all good. Very noisy. I said a helicopter. There's a helicopter. There we go. All right, so the following Venn diagrams display information about the number of elements associated with the events A and B. So for each Venn diagram, find. Okay, so the probability of A, and I might just get a highlighter here and we can erase it each time. So remember, the probability of A is the whole circle. Okay, so we're including that 6 and the 3. So the probability of A is going to be 6 plus 3, which is 9, over your total. So we've got 6 plus 3 is 9, plus 4 is 13. All right, so the next one. So I'm going to rub that out because otherwise it's going to get very messy. We want the probability of A and B. So we want this intersection part here. Okay, so the probability of A and B, so it's 3 over a total of 13. Now, this is where you use your conditional probability formula. So it's always a good idea to write the conditional probability formula. So A and B over the probability of B. So A given B is equal to the probability of A and B over the probability of B. Now, here I've written probability, but remember that's the same as the number. So you don't need to actually write the fractions up there. You can just write the number. Okay, so the same thing. So the probability of A and B we know is, oops. See, when you're talking and you're writing, sometimes I can't do two things at once. That should have been an N. Let me just rewrite that. Okay, so the number of A and B is 3. So we got 3 in there. And the number in B is going to be 7. So effectively, we're looking at, and I might just do a different color. All right, we want all of B. So we want the probability of A given it's a part of B. So the 3 is all that's a part of both B and A. So it's going to be 3 over 7. All right, let me just erase that because it's a little bit messy. And then the other one, I might just do over here. The probability of B given A is the number of A and B. You can write it B and A, it doesn't matter. Same thing, over the number of A. So this time A and B is still 3, but the number in A, which we did before, is 9. So it's 3 over 9. And then we just simplify that to 1/3. All right, so the other 3 are the same. Just when you get to D, don't forget this 3 on the outside has to be considered as your total. Okay, so these other A, B, and C didn't have a number on the outside, but this 3 you have to include in the total. All right, let's have a look at question 3. So the following two-way tables show information about the number of elements in the events A and B for each two-way table. So we're kind of doing the same thing, but this time you're doing it from a two-way table. So let's do, they're pretty much the same thing. I'm just going to do A because it's the first one there. So the probability of A. So we want probability of A, we read down is 7 over our total, which is 18. The probability of A and B. So A and B is 2 over 18, which is equal to 1/9. Now the probability of A given B is the, so we're just looking at N. What are we doing? Over N over B, NB, sorry. So we're looking at A and B, which is this number here, 2. And the number of B down here is 10. So that can simplify to 1/5. So we're looking at A and B given it's B. So we're looking at that 10. And then for the other one, it's just around the other way. So probability of B given A. So they're not the same thing. Sometimes they are, but very rarely they are. Okay, A and B over the number of A. So A and B we know is 2. And the number of A is here, which is 7. Whoops. I need to turn my emails off. Let me just finish writing this and then I'll turn my emails off. There we go. Okay, so 2 over 7 is your probability. Now, if you're sitting there thinking, why am I not doing the probabilities? It's basically you're going to get the same thing. So let's do this same question, but I'll just show you using the probabilities. Okay, so the probability of A and B we did here, which is 1/9 or 2 over 18. When you're dealing with multiple fractions, it's always a good idea to have the same denominator, and then the probability of A was 7 over 18. So already it's looking a little bit messy. Now you can rewrite a division like this. And I forgot my 1 there. Now when you divide a fraction by a fraction, you keep the first fraction the same, change the sign and flip the second. So they cancel out and we're left with 2 over 7. So you can see why I was saying you don't need to write the actual probability, just the numbers, because the denominators end up cancelling each other out. All right, question 5 I added because we weren't given a Venn diagram or a two-way table. So Let's do it from a problem. So of 15 musicians surveyed to find out whether they play the violin or the piano, 5 play the violin, 8 play the piano, and 2 play both instruments. So we're going to represent it on a Venn diagram. Venn diagrams and two-way tables always help us with the probability. So even if they didn't tell me to do a Venn diagram, I probably would have done one. Okay, so we've got 15 in total. Now, it's always good to see how many play both, so 2. So we put that 2 in there, and what are we doing? Violin and piano. So 5 play the violin. So we've already got 2 that play both, so that means 3 just play the violin, and 8 play the piano. So 2 play both, so 6 just play the piano. And what do we got? 5 play the violin, 8 play the piano, and 2 play both instruments. And we've only got 11 here, so I'm assuming there's a 4 on the outside, but I might just double check that. All right, so that's good. So the 4 is on the outside because it didn't say the musicians had to play both violin and piano, so the other 4 might play the drums or guitar or something. Okay, question B. How many of the musicians surveyed do not play either the violin or the piano? So that's 4. Okay, so we've already done that. How many of the musicians do not play either? So it's either. They don't have to play both. So either is 4. Find the probability that one of the 15 musicians surveys plays the piano given that they play the violin. So we're going to be doing the probability surveyed plays the piano given that they play the violin. So we want the number of P and V over the number of V. So we're only looking at people who play the violin. 2 play both, 5 play the violin. So 2 out of 5 is your probability. Find the probability that one of the 15 musicians surveyed plays the violin given that they play the piano. So we're just doing it around the other way now. So the probability violin given that they play the piano. So N equals P and V over the number of P. So that's 2 over 8, which simplifies to 1/4. And I think that's it for this one. And then we get to the difficult questions. Okay, bye girls.